So this lesson we want to look at the cosine rule. We've seen already the sine rule that tells you that when you have any triangle, it doesn't have to be right angled, it could be any triangle, then that can help us find missing sides and missing angles. And the cosine rule is the same sort of thing. It'll work for any triangle, and doesn't have to be right angled. And so we just need to be careful that we, again, label our triangles correctly. So the corners, the vertices, we label with capital letters, and the sides opposite those, we label with the lowercase. So there's angle A, side A is just opposite it. There's angle B, so we label the side opposite little b. Side C, side opposite it, sorry, angle C, side opposite it is little c. So capitals for the angles and lowercase letters for the sides. And the cosine rule will help us find missing sides or missing angles if we have one of these two conditions. Either if we know all three sides, then we can use the cosine rule to find an angle. Or if we know two sides and the included angle, then we can use it to find the third side. Now, included angle just means the angle between the two sides. So if I, for example, know this side here, AB, and I know this side here, AC, the included angle is basically the angle that those two sides make between them. It's the angle between the two sides that we know. Now, what is the cosine rule? Well, the cosine rule is this. It looks a wee bit like Pythagoras' theorem, so it's derived from, but a squared equals b squared plus c squared minus 2bc cosine angle A. This is why it's the cosine rule. And you'll notice a few things about this. The letter at the start, the side at the start, is the same as the letter at the end, the angle at the end. So if this is A, this is A. If this was B, this would be B. The other two sides then, B and C, are squared here, and they're repeated in this little bit here. Now it's important to know that because it means that we can rearrange this, that if I wanted to find side A, we use the cosine rule using A squared equals such and such. If we want to find angle A, we still use the same formula, which begins little a squared equals. But if I wanted to find side B or angle B, I'd have to use a formula that started with b squared, and it would end with cosine B. They start and finish in the same letter. What we do then is, instead of having a B and C here, what we will have is A and C. So we square A, square C, and then it's 2 times these two letters, AC cosine B. If I wanted to find side C or angle C, we'd use a cosine rule starting with C squared and ending with cos C. And the other two letters then are A and B. And then I repeat that to A and B. And it works with any letters. So if we had X, Y, and Z, we could say X squared equals Y squared plus Z squared minus 2 times these two letters, YZ, times the cosine of X. And so, albeit in formula books we'll be given this formula, we need to be able to change it depending on the letters that we're dealing with. So here's a couple of examples, and in this one here we're actually asked to find BC. Now this is side BC here. So the first thing I'm going to do is label this. This is angle A, so this is side A. This is angle B, so this is side B. This is angle C, so this is side C. We want to find BC, which I've called A, so my formula has to start A squared. And we're going to complete that, plus B squared plus C squared minus 2, these two letters, BC, times the cosine of what we started with, except it's a capital rather than a lowercase. And like so much of maths, once we have a formula, we just fill it in and then find out what our answer is. So A is what we want to find out. Let's just keep that as A squared. B is 45 squared plus c is 50, so it's 50 squared, minus 2 times 45 times 50 times the cosine of, well, angle A is 43 degrees. So what we can do is put that all into our calculator. 45 squared plus 50 squared minus 2 times 45 times 50 times the cosine of 43. And that comes out as 1,233.908. To find A then, just like in Pythagoras' theorem, we simply find the square root of that, and the square root of that is 35.1. And our units here, we're talking meters. So we've found a missing side using the cosine rule. Same sort of thing for this second example. First thing, let's label our side. So this is angle M, so this will be side M, little m over here. This is angle L, so this will be side L. This is angle N, so this is side N. We are asked to find LM, which is side M. So I want my formula to start M squared. The other two letters are L and N, so it's L squared plus N squared minus 2LN, and then we put the cos of the initial letter, which was M. So let's fill it in. M squared is equal to, well, this is 9 squared plus 8 squared minus 2 times 9 times 8 times the cosine of 120. Again, we can do that on our calculator all in one go. 9 squared plus 8 squared minus 2 times 9 times 8 times the cosine of 120. And that works out as 217. So if we take the square root of that, that'll get what M is, 14.7. To three significant figures. Our units here are centimeters. So again, we use the cosine rule to find a missing side on a non-right angle triangle. Last thing just to look at is how do we use that to find an angle. And if we know all three sides in a triangle, then we can use the cosine rule to find an angle. So here we're asked to find angle P. So that's this one in here. Okay, again, let's just label these. This is little p. This side is opposite q, so it's little q. This side is opposite r, so it's little r. We want to find angle P, so I need a cosine rule that starts with p squared, because that will end with cosine P. The other two letters are q and r, so it's q squared plus r squared minus 2qr times the cosine of p. Now let's fill in what we know. This time it's a slight difference because we actually know the first letter. So this is 7 squared, 7 squared is equal to 8 squared plus 5 squared minus 2 times q, which is 8, times r, which is 5, times the cosine of p. So let's fill that in. So 49 is equal to 64 plus 25 minus, now you need to be careful here, this is 2 times 8 times 5, we know is 80. We don't know what the cosine p is, so this is all one term, minus 80 cosine p. We cannot just add that or subtract it from 64 and 25 because it's not minus 80. It's minus 80 cosine p's. But what we can do is rearrange this to bring the minus 80 cosine p to the other side of the equation. And when we do that, it becomes plus 80 cosine p. We've got our 64 and our plus 25, but I'm going to move this 49 across, so it's going to become minus 49 as well. And that's 80 cosine p is equal to 89 take away 49 is 40. Now, nearly there. We want to find what cosine p is. In this case, that's 40 divided by 80, or half. And just like normal trigonometry then, if we want to find what p is, we use the inverse cosine. I'm just going to write that as a half. 40/80 is 1/2. And so p, when we put that into our calculator, we get that p is 60 degrees. One more example. Same thing again, we're trying to find an angle z. That's that angle there. That's opposite little z. Y is opposite 60, so this is little y, and x is opposite 30, so this is little x. So we need an equation involving starting and finishing in z's, because that's what we want to find. So little z squared is little x squared plus little y squared minus 2xy and cosine angle z. And let's fill it in. So z squared, 75 squared, is equal to 30 squared plus 60 squared minus 2 times 30 times 60 times the cosine of z. Can we put that into a calculator? That's 5,625 is 900 plus 3,600 minus, so 30 times 60 is 1,800 times 2 is 3,600, but that's attached to the cosine z. It's 3,600 cosine z. That's, again, very, very important that we realise that's all one term. It's a cosine z term. So let's rearrange this, take it over to the left-hand side. We get that 3,600 cosine z is equal to 4,500. That's these two added together. Take away 5,625. And when we do that sum, we get minus 1,125. And again, we don't want to find what 3,600 cosine z is, we want to find out what cosine z is. So that's 1,125 divided by 3,600. And z then, again, like normal trigonometry, if I know what cosine z is, to find what z is, I find the inverse cosine of the other side. And it is important to keep that minus sign there. We just put it into our calculator like that, so it's the inverse cosine. Use the minus sign, 1,125, and you either write it as a fraction like that, or you can write it as a division, 3,600, and close your brackets. And when you do that, we get that it's 108.2 degrees, but if we're doing three significant figures, 108 is fine.